Welcome back, Math 30-1. Today we're going to be looking at graphing primary trigonomic functions. So to start off, we're just going to look at what is a periodic function. So a periodic function is a function whose graph repeats regularly over some interval of the domain. So it repeats over time. So the interval is known as the period of the function. So its repetition part is the period. Okay? Now what is an amplitude? Another key term. An amplitude of a periodic function is defined as half the distance between the maximum and minimum values of the function. So it's half of the max and minimum values of the function. So now, determine the period and amplitude for each of the following periodic functions. So first of all here, the period, we want to know where does it repeat itself. So we go from here to here. So my period is equal to 8. Okay, because it takes all the way to here to reset. Okay, so my amplitude is equal to, from our definition, the maximum and minimum, the difference of the maximum and minimum. So I'm going to go max minus min, which is going to give me, divided by 2, 10, subtract negative 10, divided by 2, which is going to give me a total of 10. Okay? Now let's take a look at B. Well, I have here, we go from this point to this point. That's where my period repeats, so it goes all the way up, then down. And that's going to be a total of 6, so my period is equal to 6, and my amplitude is equal to, well, my max is 6, and then we're going to subtract negative 2, and then we're going to divide that by 2, which is going to give me 4. Okay? Now the last one is C. I have right here, same idea. We want to know my period. I start here, and where does it reset? It resets to right there, so my period is equal to 10. And max minus min, we're going from 6 and 2, so that is, my amplitude is 6, subtract 2, divided by 2, which will give me 3. Oops, sorry, which will give me 2. All right? Now, right here we're going to do a little exploration quickly. So graph sine x, where x is in its degrees. So complete the following table of the domain of 360. So when we're at 0, we know the value of sine of x. So this is going to be actually, from the class before, at 0 we're going to be the same thing as 0. Okay? Sine of 0 is 0. Now at 30 degrees, that is going to be small, so it's 1 over 2. At 60 degrees, that's going to be root 3 over 2. And then at 90 degrees, we're going to be 1. At 20 degrees, 120, we're going to be, that's the same as 60. If I look at my unit circle, that's the same as 60 here, is 120. So it's going to be root 3 over 2. At 50 degrees, that's 30 from 180, so that's going to be 1 over 2, and then 180 is 0. Okay, and we're going to continue this. 210 is 30, so that's going to be 1 over 2. And then we're going to have, and this is going to be negative, and we're going to have here now, 240 is going to be, that's 60 away, so that's negative root 3 over 2. And then we're going to have 270, which is going to be the same thing as negative 1. And then here we're going to have negative root 3 over 2 and negative 1 over 2. And this is going to be now the same as 0. Okay? So if I was to graph this, I'm going to pinpoint out my main ones. So we're at 0, and then 90 is at 1. Okay? Then 120, and we go back to 0 at 180. Then at 270, we're going to be at negative 1. And back to 0 at 360. So my graph is going to look something like this. Okay? And it's going to continue going. So if I went here, so 90, so I'm going to add 90 from there. That's going to give me 450. 540, and there's going to be my graph. Now, graph this on our calculator using the following format. So we have this in degrees. So when we're doing this, if we notice it's in degrees, so I have to put my mode make sure my mode is in degrees. Okay? Now I'm going to graph it, so I'm going to go y is equal to sine x. And I want to change my window to their following settings. So my x minimum is going to be negative 360. My x max is going to be 360. My scale, we're going to count by 30s. Or, oh sorry, they want my y max is 540. My scale is counting by 30s. My min is going to be, I'm going to put at negative 1.5. And my max is going to be 1.5. Okay, and scale is, well, they said 0.2. I'm going to say 0.5. And I'm going to graph it. So my graph looks something like this here. Okay, so it looks very similar to what that is. So on the grid of the graph, complete the sign. So we're going to just complete this. It's going to continue going down like that, 180, and then to 270, and then to 360. So that's what my table is going to look like. And then it says, and then now we're going to go on to question number 2. So state the following function of sine of x, where sine is defined as the set of all real numbers. What is my domain? So if I look at this, my domain goes on forever. So my domain is, we have x such that x is an element of all real numbers. Okay? We want to know now, what is my range? Well, my range of this, I take a look at it, my range is my y values is between 1 and negative 1. So we have y must be less than or equal to 1, or greater than or equal to negative 1, but less than and equal to 1. Okay? And where y is an element of all real numbers. Now my amplitude is going to be my distance from my 1, subtract negative 1, is 2, divided by 2 is going to be 1. My period for this, well, a full period is going to be 360. Okay? My x-intercepts are at 180, 360, 540, and so if we continue that, we have 0, 180, 360, 540, and we also have negative 180 and negative 360. Okay? So my y-intercepts are just at 0. Okay? If I want to continue this here, you see a pattern. It is going to be 180n, where n is an element of integers, and that's kind of the pattern that we see there as it's going up by 180 every time it hits 0. Okay, so class example number 3 says, a student was asked to reproduce a graph in the exploration of B, okay, in radian mode. Write down on the graphing calculator the format the student should use. So now it's in radian mode, we have to put it into radians. And we want our graph, we're going to have to change my windows. So we're going to be looking at x. So my minimum x, I'm going to say, is negative 2 pi. Okay? My maximum x, well, we're going to say is 3 pi, or we could just say 2 pi. And we're going to count by, we counted by 30s there, so that's the same as pi over 6. Okay? Now we're going to look at my y. So we're going to convert through negative, well, y is just going to be between 1, same thing, negative 1, 1, and 1.5 we had, 1.5, and 0.5 I would say we're going to count by. So that's going to, the y's don't really change. Now it says to sketch the graph showing the x and y intercepts. So if I was to sketch this graph quickly, it's going to look the exact same, just kind of like this. Okay, and we have 0, and my next x-intercept is going to be at 180, so that's going to be pi. This is going to be at 2 pi. This is going to be 3 pi. And here we're going to get negative pi. Okay, and the last one is going to be negative 2 pi is going to be my last intersection.